Because I got him on a stupid schedule, and then one day, it's fine. It's fine. Just feed your kids. Just the whole reason why I have them, I guess. Okay, this. Sorry, that is on camera. Okay, this is nothing to do with Mr. Skowski. Fake taught my class, and he said that looked like it was 4-9. If that was 0.
Hey, we found it. It was Caden Biggs.
It was.
Got
Rats.
it.
I'm so glad.
He's so new too. We're like, hey, do you have a pink calculator? He's like, I think I do.
I think I might have it.
Walks right up to his stuff. He's like, this one. No, the other pink calculator.
I'm glad you can read it now. So you better find that.
I'm going home.
No, even she's still scared of Mrs. Baker, and she's been graduated for like 6 years. Oh, all right, so we're gonna go from these are rectangular, and did we already do this?
I don't think so.
We have
No.
Okay.
We did the other way, right?
Okay. So this is our X and Y, so this is what we're gonna use to help us. Now, these are all, some of these are on your unit circle. If they are, you have to use the perfect radians. If they're not, then you can use your calculator. So like, these two are on the unit circle, this one's not. Okay? So, to find your angle, so we want it to be a point R theta. I guess we're going to find R first. So the formula for R is the square root of x squared plus y squared. So R is the square root of -1 squared plus 1 squared. So the square root of 1 plus 1, which is the square root of 2. Okay, so that's how you find R. How you find theta is doing the tangent, because you have a point. Now this is going to be important that you need to pay attention to what quadrant you're in. Okay? What quadrant is this in? Negative and then positive. The second quadrant. Okay, so you need to make sure your angle is between pi over 2 and pi. So when I find the tangent, theta equals y over x, so 1 over -1. That means I need to find where is tangent -1. Okay, now you can use your calculator if you want to, but it's not going to give you the perfect radian. So you could do like your calculating degrees and then convert later, or if you just remember, or you like or look at your unit circle, it's 3 pi over 4. If you use your calculator and you have your calculating degrees, you're going to get -45 degrees. How would I convert that to positive? It's in quadrant 2. Add 180. Okay, do you remember how to convert from degrees to radians?
Times pi over 180.
Pi over 180. And this is a problem on your final review guide. So, might be a good review. Either pi, this way it's pi over 180. If you're going the other direction, it's 180 over pi. So then my point is square root of 2, 3 pi over 4. Now, if they're not on the unit circle, like when we get to number 9, you'll just put your calculator radians and just round to 2 decimal places.
Can you explain how you got -5?
If I did, so this is what I have, and I went to my calculator, and I did tan inverse of -1, and my calculator's in degrees, this is what's going to give you. Okay? Okay, so number 8, we're doing the same thing. So to find R, square root of 0 squared plus 2 squared. Square root of 0 plus 4. Square root of 4, which is 2. Okay, then tangent is undefined. Okay, so what angle would that be? Okay, well, if you're not sure if it's undefined, so on your tangents, you're getting, your options are 0, square root of 3 over 3, 1, square root of 3, or undefined. Now, those could be negative if it's on the unit circle. Okay? So if it's undefined, think about where is the point 0, 2 at? So if I were to plot 0, 2, where would it be? Straight up, right here, right? So what angle is that?
Pi over 2.
So my theta is pi over 2.
You dropped the word.
Okay, what if it was 0, negative 2?
3 pi over 2.
It'd be down here, so it'd be 3 pi over 2. Good. Alright, so my point is r, and then theta, so 2 pi over 2. Okay, then number 9. R is the square root of negative 3 squared plus 4 squared. So square root of square root of 9 plus 16, which is the square root of 25, which is 5. Good. Okay, now if I find my tangent, negative 4/3 is not on your calculator, or it's not on the unit circle. So I'm going to do tan inverse of that number and make sure your calculator is in radians. Because you want your theta in radians. Okay, so I got negative 0.93. Okay, number one, you can't have a negative angle. You have to fix that. So what quadrant is this point in? 2. So how would I fix that? Okay, so what's 180 in radians? Pi. Okay, what if it's in quadrant 4? What do you add? 360, which is what in radians? 2 pi. So theta is actually 2.21. So my point would be 5, 2.2. I think this is the hardest part. Because you have to know the quadrants, you have to know like tangents of angles. Is everybody okay on this? The whole point of going from a rectangular to polar form is you have to get rid of all the x's and y's. So everything needs to be replaced with r's and thetas, okay? And then you would solve your equation for r. So the only thing we really know are these things down here. We know x is equal to r cosine, y is equal to r sine, and then we know our r equation. So what could I do with number 10?
Change the X and Y to the
Okay, so I could change it to this. Is there an easier way?
Squared, make it r squared.
Okay, so x squared plus y squared is r squared, right? So if only this only works if you have squares. So I can't do this on 11 and 12. But if you see something that's squareds, try to see if you can use this equation, because it makes your life so much easier. Because I can replace this with r squared equal to 9, and then how would I solve that just for r? Square root it. So then r equals plus u. Okay, you do not have to do plus or minus on these because this is a distance, and distance aren't negative. Okay, so if they're squares, always look at this equation. Otherwise, if they're just x and y, we're going to replace them with r cosine for x and r sine for y. Okay, so if I'm doing number 11, this x, I'll still have my 3, but my x is going to become r cosine theta. And then minus, and instead of y, I have r sine theta. And then plus 2 equals 0. Okay, so to solve for r, I gotta get the parts that have r by themselves. So I leave these two over here and move the 2, so I subtract 2 from both sides. So I have 3r cosine minus r sine. Okay, so now to solve for r, these both have an r in them. So I'm going to factor that out. So I factor out the r, so I have 3 cosine theta minus sine theta. And then how would I move 3 cosine theta minus sine theta to the other side? Divide. So r would equal negative 2 over 3 cosine theta minus sine theta. Okay, now if those were like multiplied, the goal is to not have any fractions in the end, okay? If it's adding or subtracting in the denominator, you can't really make it more simplified than that. But if these were multiplied, we can move them to the top by using your reciprocal identities. So like reciprocal cosine is secant, reciprocal sine is cosecant. Okay? If you don't remember, they're on their sheet or like the front of your book. Okay, last one. Neither one of those are squared, so we're going to use r cosine, r sine. Okay, these are multiplied together, so this is r cosine times r sine. Okay, well r cosine times r sine would be r squared cosine sine. Okay, then what would I do next to get rid of, or to get r by itself? Okay, so those are all multiplied together, and so we would divide. So then I have r squared equals 16 over cosine sine. Okay, now since those are multiplied, you can move those to the top. So like reciprocal of cosine is secant. So this becomes 16 secant. And the reciprocal of cosine is cosecant. And then what would I do last? Zero to the squared. Now, yes, you can take the square root of 16 and pull the 4 out and leave everything else in. But if you want to just leave it all in there, that's fine. And that would be your equation. Okay. If it makes you feel better, if you know that's a perfect, you could leave it like this. Okay. All right, that's it.
Was that yours or all of these?
Mm-hmm.